Right. So this session, this definition of robotics is defined by Robot Institute of America. So it says a robot is a reprogrammable, multifunctional manipulator designed to move material, parts, tools, or specialized devices through variable programmed motions of the performance of variety of tasks. So when you just read this, it may be a little complicated, right? It is little bit difficult for us to understand the definitions, but that is okay, right? Because still we are learning, and in the end of this course, you will be understanding what is actually a robot, right? So therefore, we will move on with keeping this definition in your mind. So simply speaking, robot is a reprogrammable, multifunctional device, right? So reprogrammable means you can reprogram it. You can program it as much as you want, right? And you are the one who programmed the robot. You are the one who's telling what to do, and then the robot will move materials, right? So it is physically moving. It can have wheels to walk, it can have wheels to drive, or it can have legs to walk, right? Or else the robot can be a fixed, it can be like a robot arm, right? So it is moving in a way that we want it to move, right? So that is the idea. So it has many functions. One can move fast, one can move very slow, but very accurately, like such. Robots, again, robots are reprogrammable devices, right? So we as humans, we can program the robot as we want, right? So that is the simple idea of this definition. And if you have any questions at any point, please feel free to unmute your mic and ask, okay? Right. So there are 3 laws of robotics. Okay, so like humans, like us, like we have laws, right? So we have to live according to these laws, right? Otherwise, police will catch us, right? So likewise, there are 3 major laws for robotics. So there are, it called 3 laws of robotics, right? So let's see what are these 3 laws, right? So number 1 is robots will never harm human beings, right? So simply speaking, robots can't harm any human being, right? So you can't program a robot to harm a human being, right? So that is an international law, right? So you can't design a robot in a way that it will be harmful for humans. Yani මිනිස්සුන්ට damage එකක් මිනිස්සුන්ට මොකක් හරි දෙයක් කරන්න පුළුවන් robot කෙනෙක්ව හදන්න බෑ, right? So first, number 1 rule of robotics is robots will never harm human beings, right? So we are not designing robots to harm human beings, right? And then let's check the second law, right? As a second law, we can see robots will follow instructions given by humans without breaking law 1, right? So it should be actually, right? Then and here I will edit this. It should be without, right? So robots will follow instructions given by humans without breaking law 1, right? So robots will follow instructions given by human. So the first law is robots will never harm human beings, right? And then, so then anyways, robots are following instructions now. So that's how they work, right? So they can work by themselves, but we are the ones who are giving them instructions, right? So robots, as a second law, robots will follow instructions given by humans, right? So robots will not follow instructions which is given by another machine or which is given by another robot, right? These are laws. So when you create or when you make robots now and even in the future, you need to follow these laws, right? So you need to build a robot which only takes instructions from another human, from us. And that is what we are trying to do as well, right? So as a second law, again, robots will follow instructions given by humans, but without breaking law one, which means without harming another human being, right? So I think that is clear. And if I'm too fast, please let me know. Right. So as a third law, you can see robots will protect themselves without breaking other rules, right? So therefore, the third law is actually robots will protect themselves, right? So robots will not harm themselves as well. So when you look at the internet, and you can see that there are even robo fights nowadays, right? So these are competition, these are sports, right? So there are like even movies, there are movies which were made in according to that topic, and there are other games, right? So robot fighting as such are there, but those are games, right? So those are special games, and that is a different story, right? But generally speaking, robots will protect themselves, right? And at the same time, they won't harm any human beings or any animal as well, right? So of course they are not meant to harm animals also, right? So these are the three major laws of robotics, right? So that we should know. So whenever we are building a robot, we should consider these three laws, and we should design it accordingly. So I think three laws of robotics are clear for you now. Right. So in the next slide, we have characteristics of a robot, right? So let's see what are these characteristics. So there are actually 6 characteristics, main 6 characteristics of a robot, right? So the first one is appearance, right? Appearance කියන්නේ පෙනුම, how the robot looks. The appearance of the robot is the number one characteristic, right? So depending on the appearance, we can categorize it again, or we can identify this robot as a robot which do these types of tasks, but not these type of tasks. Likewise, appearance is the number one characteristic of a robot. And then the brain of the robot, right? So what type of a brain, or what is the brain of the robot, right? So the robot has an appearance, right? Like all of us, like all of the animals in the world and all of the humans in the world, we have our appearance, and then we have a brain as well, right? So likewise, even a robot has a brain, right? So that is where the robot is safe. Robot saves its instructions now, right? So robot has appearance, and robot has a brain, and then robot has sensors, right? So I told this even in the other lecture as well, in the introductory webinar as well. So we humans have 5 sensors, right? So you have 5 sensors, I have 5 sensors. What are these 5 sensors? Let's say we start from eyes. We have one sensor, one type of a sensor here. Our eyes is a sensor, and then we have our nose, that is another sensor, and we have our tongue, right, to taste. So that is another sensor. There are 3 now. And then we have our skin, right? So we feel things, or we feel temperature, we feel warmth, and we feel coldness, right? So that is again another sensor. And then we have our ears, right, to hear, right? So using these 5 sensors, we can actually identify, or we can have an understanding of our surrounding, right? Which is very simple, okay? So when you see there's a ball coming towards you, like let's say we all play cricket, right? So let's say we see the ball is coming towards you, right? So now you are a batsman, right? Let's say you are a batsman and you are ready to hit the ball, right? So you can see, first of all, you need to see, okay, so the ball is coming towards you, right? And then you need to have some understanding whether the ball is still far away or the ball is really close by to you, right? And then depending on that image, like, so you can identify from your brain, okay, so the ball is coming towards me, and then at the right moment you stroke, right? You wave the bat and then you hit the ball, right? So for that we need to have this sense of eyes, right? So we need to see whether the ball is coming, and sometimes we even use our ears as well to hear the surroundings, right? Even in cricket, right? So then in the other hand, let's say like you are eating something, right? So when you are eating something like bitter, you can understand, okay, so this is bitter, right? That is from your tongue. And when you can hear noises, right? You can listen to music, right? Or else if you hear like a big sound, you know that that is a dangerous place to stay, right? Or if not, like if you feel like it is very warm or it is like burning, when you touch a device, let's say like when you touch a device and you feel like it's burning, right? So then that ability to sense that is necessary for us, right? So that those are sensors. So likewise, even robots have different sensors, right? And as an example, a line following robot has a sensor or sensor system to identify a line, right? So not all the robots uses the 5 sensors that we have or similar sensors that we have, right? It's not a necessity, right? So robots may have a camera. Sometimes robots even use cameras, just like us, to see the world. But some robots, they don't need cameras. They just need other sensors to measure the distance, right? To get an idea how far an object is, as such, right? And then a robot has actuators as well. So you can see, you can see as the fourth characteristic, right? So the fourth one is an actuator, right? Even humans, even us, we also have actuators, right? Can somebody tell me an example for an actuator that we have?
What is the question?
Can someone tell me, if you know, right, an actuator that we have? Something that we can move is an actuator simply.
Like legs.
Exactly. Very good. Right? So yes, that is correct. So legs is an actuator, right? And our hands is again an actuator. And even our vocal cords and the tongue is also sort of an actuator, right? So otherwise we won't be able to speak, right? So with legs, we walk. With our hands, palms and fingers, we touch and we grab things. These are actuators, right? Things which can move or things we move to do a task is basically an actuator, right? So even robots have actuators, right? So there are robots which has wheels. There are robots which have wheels, right? So from rotating the wheel, the robot is moving. And then some robots have legs, right? And then some robots have like wings, right? And then some robots have these hydraulic actuators, right? So likewise, some robots, I mean, they have motors, they have, so these legs or wheels are connected to motors, right? So then some robots have motors in them. So that is an actuator, right? And then some robots have pneumatic, which means which actuators which work from compressed air, right? So if you ever get a chance to visit a factory in the future, or if you have already, then you will see they are like these arms moving up and down, front, I mean forward, likewise. So these are actuators which is which works from pressurized air, compressed air. We call those actuators pneumatics, right? So there are different actuators. So we can have like servo motors, stepper motors as actuators. And then as a fifth characteristic, we have program, right? So program is actually what we code, is the code, right? Program is the code that we write. So in there, we say, okay, do this, do that. Okay, so get the information from this. Likewise, we program. We are the ones who are telling them, we are the ones who are telling the robot to do such things, right? Follow the line or measure the distance and move forward. So that is the program, or else the code that we write is the program of a robot. And then as a last characteristic, we have behavior. Behavior is a little bit complicated when we just look at it, right? But it is not. It is very simple. Behavior is actually a characteristic which says what the robot do, what the robot does, right? So by looking at the robot and how the robot move, we can understand the behavior of the robot, right? So just because there's a robot with 4 wheels and few sensors, right? So let's say there's a robot with 4 wheels and few sensors, right? So it has an appearance, and you know there's a brain, you know there are sensors, you know there are actuators, and you know that there is a program. But what is that robot doing, right? It can be a line following robot, right? Or it can be a robot which follows something else, right? It can be a robot which take things from one place and place it in another place, right? So by looking at the robot and looking at what the robot does, we can tell what is the behavior of the robot, right? So these are the 6 characteristics of a robot, right? So one is again appearance, and the second one is brain, and third one is sensors, and the fourth one is actuators, and then fifth one is program, and then we have the behavior, right? So these are the 6 characteristics of a robot. If you have any questions, please ask, and we will now go into little depth of each of these characteristics. Okay. So first, like I said, I basically explained all of this, right? So appearance is what? A robot's physical body, right? So every robot has a physical body, right? So robots have a physical body. So you can see this is given in this picture. Now the physical body of this robot is the appearance, right? So you can see it's a wheeled robot. So this robot may travel or go as a I mean, like it'll rotate these wheels and it'll move forward, backward, sideways, right? And then the appearance, the other part of the appearance is they are held by a structure of their body and are moved by their mechanical parts, right? So the robot appearance is not just for the looks, okay? Appearance is not just for the look, but for the functionality as well, right? So these 4 wheels of this robot is not for the looks only, right? It is for the function of the robot as well. Now you can see there's a big chassis. This is not just for the looks. It is to support all the components. So you can see there's an arm as well here. So that is also a structural thing, right? So which helps the robot to do the tasks. So that is the appearance, not just the looks, as in not just for the looks, right? For the functionality as well. So that is a appearance. And then every robot has a brain, right? So the brain, or the device that we are talking or we are going to learn about, is actually Arduino, right? So this Arduino board is actually the brain of the robot that we are going to make, right? That we're going to learn, right? So Arduino is the brain of our robot, right? So let's see, like, what are these, what are the components of the brain, right? So onboard control unit. So we call this brain onboard control unit as well, right? So control unit means from this is the computer of the robot, right? So from sensors, it gives us information, and then this brain or this microcontroller. So Arduino is a microcontroller, right? So this is an onboard control unit, right? So this takes information from the sensors and give instructions for the actuators to do this, right? So see the line, look at the line, or see the line from the sensors, and then it tells the motors to drive forward, right? So that is how a line following robots are working, right? So like I said, for the brain, there's another word, which is the control unit. Onboard control unit is the brain of the robot, right? So just like human brain, this robot's brain, right? Brain of the robot is responsible for its movements, right? So robots, so this brain is the part which is responsible for the robot's movement, right? So this is where we code as well, right? So we code this brain or the control unit. And then the other characteristic and the other component of the brain is, with the brain, robot knows what to do, right? So without the brain, it is just sensors and actuators and a chassis, right? But from the brain, the robots know what to do, right? So like simply saying, we code the brain, and then robots can work autonomously because of this brain. Now see, in the future of the world also, there are going to be autonomous robots, right? So how these robots can work autonomously is also because of their brain, right? So higher the brain capacity, or higher the or else like the complexity of this control unit, or more powerful control unit, can actually handle something like artificial intelligence or machine learning, or these autonomously driven softwares, right? But even for us, a line following robot is actually an automatically driven robot, right? It is an autonomous robot. So that is the second characteristic of a robot, which is brain. Okay. So let's go to the other slide. And then, right. Okay. After brain, we have the third characteristic, which are sensors, right? So I spoke about these sensors now. So like humans, robots need to know their environment in order to perform tasks, right? So robots has to know what is going on in the environment, whether there's a line to follow or whether there are other magnetic strips to follow, right? So robots need to learn. Robots need to know what is the environment is like, right? So how are they going to know about this environment is from sensors, right? So these sensors can be different. There are various types of sensors, okay? So I haven't named this because there's a separate section for us to learn about sensors and how to connect it to Arduino and how to operate it. But the first sensor given here, right, is called DHT11, which is a temperature sensor, right? So this sensor can measure temperature, right? So if your robots need to know what the temperature is, you can add this sensor, right? And then this is a IR sensor, IR transmitter and receiver sensor. So this we can use actually an array or set of these sensors we can use to see, or we can use to detect a line in a line following robot, right? So this is a IR sensor, and here you have an ultrasonic sensor, right? So this is an ultrasonic sensor. We can use this to measure the distance, right? How far is one object is, right? So this is an ultrasonic sensor, and here again we have another sensor, which is a pressure sensor. This is an atmospheric pressure sensor, right? So likewise, there are various types of sensors in different shapes and colors, right? So and there are lots and lots of sensors that we can use with Arduino, and there are sensors which are not compatible with Arduino as well, but we are going to use sensors which works with Arduino. Arduino වලත් එක්ක වැඩ කරන්න පුළුවන් sensors තමයි අපි පාවිච්චි කරන්නේ throughout this course, and from that you can build a really great robot, right? So we are using sensors which are compatible with Arduino, right? And then as a second component, you can see from the sensors, robots gather information about their surrounding, right? So the first one says, robots need to know, right? They have to know what is going on in their environment, their surrounding. And then sensors are the devices that they can learn, that they can get to know what is going on in the surrounding, right? So that is how they see, that is how they experience the surrounding, right? So do you know, like we as humans, we can see colors, right? We see many colors, red, blue, green, as such. But when you look at, when you consider dogs or cats, they see the world in a different way. They don't see colors as much as we see, right? And when you look at bats, they don't actually see the world like we see, right? So a bat has a ultrasonic sensor, something which is working to the similar operation of an ultrasonic sensor, right? So the bats see the world, or they see the surrounding in a different way. And as humans, we see the surrounding in a different way, right? So likewise, different robots can see their surrounding in different ways, right? So then there is no rule for us to use sensors. We can use whatever the sensor we want in order for us to do the task that we need, right? So that is the idea. And then these sensors have circuits which produces voltage in them to communicate, right? So all of these sensors, they have to communicate now. They have to tell, okay, so this is the temperature. Okay, now this is a line, right? Okay, so now this is the distance. This is the pressure. Likewise, they need to tell us. They need to tell to the control unit. And how are they communicating? They are communicating with voltages, right? So this we will learn separately when it's come to the sensors lecture, right? How the sensors work. And we don't need to understand exactly how the sensors work in order for us to work with them, right? So sensors, they produce small voltages, different voltages. That is how we communicate. That is how the sensors are communicating with the control board, right? And if you have any questions, please ask. Okay. Any questions?
No questions, sir.
Yes.
No questions.
No questions. Okay. All right. Is it clear what I'm telling you? You understand?
Yes. Yes, sir.
Brilliant. Brilliant. Okay. Right. So these are very simple things, right? And now we'll go to actuators, right? So like you said, now we have legs, right? So that is an actuator, right? So robots also might have legs, or some robots might have wheels, right? So these wheels, how the wheels are rotating, or how the leg is functioning, right? So how it functions, how a wheel rotate is using a motor, right? So motors are very famous actuators, right? So there are three major types of motors. I have given here two types. So this one If you can see my cursor, this one is a stepper motor, and we will learn thoroughly about this in the future, right? So this is a stepper motor. It works in a different way. And this is a servo motor, right? Servo motors, we can tell what degree to turn, whether it's 90, turn 90 degrees, turn 180 degrees, or 45 degrees. Likewise, we can tell this motor to turn it to a certain direction or to turn it to a certain number of degrees, right? So that is a servo motor. And here we have, I have given you an example or image of a pneumatic actuator, right? So first you need to supply a pressurized air here, right? And then there's a small switch here. So that is what we control from our Arduino, right? So in the future, you may be able to use these pneumatic actuators. And in this course, we are not going to use pneumatics because it's a very complicated system, right? So you need to have compressed air. Then you need to have compressor to power up these pneumatic actuators. But in very powerful robots, very strong robots, they use these pneumatic actuators, right? But even this actuator is controlled by a brain, like an Arduino, right? So let's look at the components. So like humans have arms and legs, robots also have parts which they can move in order to perform tasks, right? So robots also have parts which they can move, right? Which they can rotate or which they can extend, extract. Likewise, there are different parts in the robots which they use to do their tasks, right? So how these legs or arms or wheels are working, they work because of a motor, right? So motors are actuators, right? Like it says here, some actuators are motors, hydraulic actuators, and hydraulic actuator is another type, and then compression actuators, like pneumatic actuators, which is given here. So there are various types of actuators as well, right? And the brain tells these actuators when and how to respond or move. So like I said, brain is the part which tells these actuators to move or not, right? So these are actuators. And then it comes to the program, right? So the fifth characteristic of a robot is a program or the code, right? So we're going to code using Arduino in this course, right? So robots only work or respond to the instructions which are provided to them in the form of a program, right? So robots only work. So in the beginning, I said, robots will follow instructions given by humans, right? So that is also one law, right? I think it was the third law of the robotics, right? So robots are always following instructions which is given by humans. And how are we giving these instructions? By coding in the form of a program, in the form of a code. That is how we tell these robots instructions, give these robots instructions, right? So we give instructions in a form of a program. So in our case, we are using Arduino IDE or Arduino language. We can say it's C language, right? So that is a programming language, and that is how we tell robots what to do, right? And these programs tell the brain when to perform which operation, like when to move or produce sounds, right? So this is the program that we put into the brain of the robot, and that is how the robot is functioning, or that is how the robot move, or that is how the robot produce sounds and all, right? And that is also how the robots see the world, right? So we need to tell the robot, okay, get distance from an ultrasonic sensor, right? Detect a line from an IR sensor. So that is also the code. So I think you have a rough idea about the program now. And then the behavior, right? So like I said, the sixth and the last characteristic is the behavior. So by looking at the robot, robot's movement, we can identify the behavior, right? So robot's behavior is decided by the program which has been built for it, right? So how the program, so whether if it's a line following robot, or whether if it is a distance following robot, whether if it is a heat following robot, right? So that is the behavior of the robot. And once the robot start making the movement, you can easily tell which kind of a program is been installed, right? So whenever at the point that you see, okay, so this robot is following this line, then you can understand, then you can identify the behavior of this robot. So this is a line following robot. Likewise, that is a sixth and the last component, last characteristic of a robot. And if you have any questions, please feel free to ask, okay, at any point. Okay. So because you don't have any questions, I'll move forward.
No programming with app or web.
Sorry, can you repeat the question again?
Do you know programming with app or web?
Yeah, so there is a small application. There's a small software. Yes. What is software එකක් අපි install කරනවා අපේ computer එකට, so that we can code from Arduino, right? So Arduino introductory session will be on the other class, right, as the lecture 2, and I will teach you and guide you how to install Arduino and to program from it, right? So that comes in the next class, right? Okay, I think you got a clear answer for that question. Okay, so let's go to the other section, which is types of robots, right? So there are a few types of robots, and I explained you about these types of robots in the previous webinar as well, right? But let's go through that again. There are a little bit more in this slide set, right? So there are a few types, right? So there are various types of robots nowadays, right? And there are various ways of categorizing these robots as well, right? So mainly, right, so there are these types which are articulated, which are Cartesian, cylindrical, polar robots, Cara, delta robots, and legged and wheeled, something that we are familiar with. And then AUV, autonomous underwater vehicles, and AUAV, unmanned aerial vehicles, right? So likewise, there are different types of robots. Let's quickly go through them. So articulated robot is actually a robo arm. An example for an articulated robot is a robo arm, right? So which has rotating joints, rotary joints, right? So this feature of this robot is its rotary joints, and range of these are from 2 to 10 or more joints, right? So generally these articulated robots have 2 to 10 joints, right? So you can see in this example, there's one rotating joint here, there is one, and another one here 2, another one here 3, and there's another one here 4, there's another one here 5, 6, and probably here also there's one 7, right? So this robo arm is consisted of 7 rotating joints, right? So this is an example for articulated robot. And then there is a Cartesian robot. Have anyone of you seen a 3D printer? Have you seen a 3D printer?
Yes, sir. Only in videos.
Yeah, okay, brilliant. So in videos, you can see a 3D printer is something like this, right? So there is this in here. So this is not a 3D printer here, right? This is a Cartesian robot, right? So you can see there's this in a 3D printer, this is the print head, right? So the filament is coming from here, coming from somewhere and joined here, and this is the print head. So this print head moves to the right, to the left, up and down, right? So a 3D printer is not a robot, but it has almost all the components of a Cartesian robot, right? And these robots are known as gantry robots as well, right? So these robots can move. So this is the point, right? So this point can move backwards and front and to the left and the right, as well as to up and down, right? So let's say there's an object here. So this robot can move this point to here and grab that object and lift it up and go back and then come again to its right and then drop the object here, right? So this robot can move this object, if there's an object here, from here to here, right? So Cartesian robot is something like a 3D printer. Like 3D printer has all the mechanical the appearance of a Cartesian robot, right? So this Cartesian robot have 3 joints which use a Cartesian coordinates. So I think like we draw graphs, right? X and Y graphs, and then there's another side which is called Z, right? So left, right, and up and down, right? So when you keep your hand, right hand or left hand like this, so you can see, right? So this is one direction, and this is another direction, and this is another direction, right? So we can call X, Y, and Z, right? So likewise, robot can move to the left or to the right or front or to the back or up or to down. Likewise, a Cartesian robot is a robot which can move from X, Y, and Z planes, right? And we will learn more in the future coming sessions, right? And then we have a cylindrical robot. So as you can see in the slide, these types of robots have at least one rotary joint and one prismatic joint, which are used to connect the links. So what is a prismatic joint? Prismatic joint is actually something which goes up inwards or outwards, right? So a cylindrical robot has one rotating joint. So as given in the picture, so it can rotate across this axis and then it can go up and down, or it can go, you can expand this axis as well. Yes.
Can the robot can go the left and right?
Sorry?
Move the robot can move left and right?
This robot can't move left and right, but it can rotate, right? It can rotate and it can lift and this robot can rotate from this axis, and then this part it can raise or decrease, right? And this component also, it can go like to the left and to the right, right? So this is also a robot, but it is limited, right? But this robot can't move. It can't move from one place to another, but it can move this component to different places using the axis.
Move the robot, only move the part.
Yes, exactly. It can only move the parts. Yes. So it can actually grab an object from one place and place it in another, but it can't move, right? Only using these joints and these rotating things, it can do some movement, right? Clear?
Yes, sir.
Okay, brilliant. Right. So this is another type of a robot, right? So which is called Polar, right? So it also has similar characteristics, but it has different types of joints, right? So these are actually robo arms, right? And then this is also another type of a robo arm. So this is called a SCARA model. So it has actually one, two rotary joints, and here also it can rotate. So here also it can rotate. So 1 and 2 rotating joints, right? So that this is also acting as a robo arm, and this one can expand, right? So like just have a very simple idea about it, and that is enough, right? And then we have this type of a robot which we call Delta, right? So Delta is also consistent of motors, right? So it has 3 motors. Okay, so it has 3 motors, and it also something like a robo arm, right? So the structure of these robots are like a spider shape, right? It's like a spider. So this also, this head, we call this piece the head of the robot. So this head can be moved to one place to another using these motors on the top, right? So this is again a stationary robot. This robot also can't move, right? But it can use to grab something from one place and drop it to another place, right? And then we go to the other type. So this is the type that we are more familiar with, right? So in this example, the picture towards to your left is actually a wheeled robot. So it has wheels, as you can see, right? So it is a wheel robot, and to your right, this is a legged robot. So you can see this robot has 4 legs, right? And then these are other types of robots. So this is a unmanned aerial vehicle, UAV. So you can see it is a drone, so it flies. Aerial vehicles are flying robots, right? So this can autonomously fly. And then you have this underwater diving robot. So this robot can dive and do some tasks autonomously, right? So these are few types of robots. Okay, right.
Okay.
So let's move to the technology of robots, right? So what are these technology? And I took this slide from the webinar, right? So when you look at a robot, you can see there are 2 types. One is intelligence, and the other part is machine part, or the mechanical part, right? So this mechanical or the machine part can be again divided into two. One is electronics, right? So all the circuits, all the sensors, the Arduino board, these are electronics, right? And then the mechanical, right? So the motors and how the wheels are connected to the motors, or how the legs are connected to the motors. So that is a mechanical part, right? And when it's come to intelligence, or when it comes to the brain, one part is AI, artificial intelligence. So that is coming in the future, right? And then what we're going to talk about is the programming or the coding part, right? Okay. And then, and I think you all have been there in the webinar as well, so I'm not going to go through this a lot, right? And then this is also another slide that I took. So this also I explained you during the webinar, right? So in the middle, we have the controller, or else the brain of our robot. And then we have a power conversion unit to power up different components. We need different levels of voltages, right? So for that, we have a separate power conversion unit. It can be a circuit, right? And then we have sensors and actuators. To sense the environment and do the tasks, we have actuators. And to sense the environment, we have sensors, right? So it's all connected to the controllers. And then we have user interface, right? So if the robot is communicating with us, the robot can use a user interface to do that. And then the manipulator or linkage base means the chassis or the solid point, right? So these are the key components of the robot, and I explained you this in the webinar session, right? So therefore, I'm not gonna go through it again today, because with time, with the coming forthcoming lectures, you will understand this picture further, right? So as an exercise, let's do some practical, right? So let's go to Tinkercad, right? So I hope you all, I think you all have come to this class with your laptops, right? Can you tell like whether you have come, whether you have participated to this session from your laptops or from your mobile phone? Do you have a laptop near you now?
Yes, sir. I am participating with this laptop.
Right, brilliant. How about others?
Sir, me, Hima.
Yes, Simal, you have a laptop next to you or near you?
I join now the laptop.
All right, okay. All right,
I'm participating in the laptop too.
right, brilliant. Okay. Right, so since we all have laptops now, let's start doing this exercise, right? So I will explain you what is this Tinkercad. You can try Tinkercad when you have free time, right? Okay, so let me stop sharing the screen for a moment.
Sir, can they share this file to the WhatsApp group?
Yes, I will send it to the WhatsApp group, okay? You mean the
Okay, sir.
slides, right? Right, okay. So let me share my screen. Wait. Okay. Can everybody see my Google search? Can you see the Google
Yes, sir.
search? Brilliant. Okay.
sir.
So I want you all to to type Tinkercad in your Google account, in your Google, right? And do you all
Okay,
have
sir.
Google accounts with you? Like, have you
Yes,
signed
sir,
in?
I have Google.
Yes, sir. I have one.
Okay, brilliant, right? So when you type Tinkercad in Google, right? Select the first line, right? So it says www.tinkercad.com, right? Select this one.
Do I have to sign in?
Yeah, wait, I will explain that part, right? Right, so wait, let me sign out. Let me log out. Right, so you all are getting a desktop like this, right? Is this what you get as well? Is this the window that you get? Can you tell me?
Yes, sir. But yeah,
Okay.
that one.
So in here, you can see there are two options, sign in or join now. So I want you to select this sign in, right? And then you'll be getting a window like this, a page like this, right? You all have this page?
Yes, sir.
Right, brilliant. So in here, I want you to sign in with Google, right? So which means if you have logged it with your Google, then when you press this, automatically it will go to a window like this. So it takes some time to load up. So do you all have a similar window like this?
Yes, sir.
Yes. Okay. How about others? The Hamsa, Ayodhya Himal.
Yes, sir.
Brilliant. Okay. So in here, right? So this is a tool that you can use, right? It doesn't matter for this course or in outside of this course also, this is a tool that you can use, right? And in here, as you can see, if you can see my cursor here, to the left, there are few components that you can select. You can select 3D design, you can do some basic 3D modeling as well. And today we are going to select these circuits, right?
Sir.
Sorry, do you have any questions? Okay.
Sir,
Yes.
No,
I
sir.
have an experience of creating 3D models because when I was small,
Brilliant.
I created some models with Blender.
Brilliant. That is amazing. Yes. So in Tinkercad also, you can do some 3D designs, right? But here we are going to majorly use these circuits, right? So we are going to build circuits using this Tinkercad, right? So, I mean, these are the circuits that I have created. So you may not have them with you, right? So then I want you to press this create new circuit button, right? So it's okay. You might not have, you don't have all of these circuits here because this is what I created, right? So all the circuits that you create is saved, right? But we are going to start a new circuit. So therefore, I'm going to select this create new circuit button. It'll take some time depending on the internet speed. I think mine is a little bit slow today.
My one's done. Loaded.
Okay, brilliant. Okay.
It's like a 3D model maker, no?
Yes, somewhat similar. Yes. Right. So I think my one is also loaded. Have you all got this screen by now? Otherwise, we can wait.
Wait, sir.
Sure, I'll wait. Just let me know when you all get to this window. When it's loaded, please let me know.
Okay, sir.
Okay, brilliant. So, Himal, the Hamsa, did you get the screen?
Yes, sir.
Yes, sir.
Right, so you all forgot it, right? Okay. So this is actually a very simple interface. This is online simulating tool, right? So you can simulate. So it's the same as you are physically connecting an Arduino board. We can do this online, right? So until
Sir, there is also a microbit
yes,
that
there is
I
also
learned for the
all
last
right.
course.
So you did microbit in this Tinkercad.
Yes, sir.
Okay, brilliant.
I
Right.
did.
Okay. So let's I'll go through this from the beginning, right? Because not everyone has gone through this. So right. So this is a simple interface, as you can see, right? So if I start from this side, so this is to your left hand upper corner, right? So you can see this is the name. So this software is always like prepare, it always automatically generate a funny name, right? But you can always change it by pressing it. I'm gonna rename it. You can rename it in any way you want, right? So I'm gonna rename it as robotics lecture 1, right? So you can rename it. So this is the name of the file, right? And then if I come here, these are some keys that we can use, right? So this one to the most, so the leftmost button in the upper left hand side, so this is a rotating tool, and I will show you this, right? So by pressing this, you can rotate the component, and this is of course the delete, and this is backward, or which is undo, right? And this is redo, and here you have labels, right? So it is notes, labels as such. And here also there's a button. So when you press this button, if there are many labels, you can just clear the visibility by actually hiding the labels, right? So this is also another button. And then here you have colors. So if you need wires, if you need different type of wires, different colors of wires, you can select out of these colors, right? And then here is a type of wire types, right? So the normal wires, the hookups, alligator clips, and there's one called automatic as well, right? But we're gonna learn, so then we are going with this normal and other methods, right? So these are the buttons to your left. Clear?
Yes, sir, clear.
Right. And then this large area, right, is your workspace, right? So this is where you're going to build your circuit, right? And then for now, I'm not going to tell anything about these 4 buttons, right? So which is to your right hand side: code, start simulation, export, and send to, right? I'm not going to discuss about that just for now, right? And here you have circuit view and component list if you want, and then you have your own personal details here. My connection is a little bit slow, I guess. Right, anyways, so always make sure that this is here, all changes saved, right? Because whenever you do something, this automatically saves your work, right? But sometimes, depending on your internet speed, it may take some time. It may take longer time to save, right? So when it's saving, it indicates here as saving, right? So please make sure that you don't close this when it says saving, right? So because it's saving at the moment, don't close the tab, right? And when you can see all changes saved, then you can close the tab and exit, right? So that is something that you should keep it in your mind, right? Okay, so then we have this drop down menu for components, and in this drop down menu, the first part is components, basic and all, right? So if you select basic, which is already selected here, basic, it only shows the basic components, right? But by pressing all, you can see all the components which are here, right? And I recommend you all to select this all components all the time, right? Because then you always see what are the components which are available, right? And here as starters, you have basic circuits. So these are different circuits which they have built already in this Tinkercad, right? But we are not going to use starters, right? If you want, you can try at home, right? Try it yourself, but in the class, we are going to build circuits, right? So that is the entire idea, right? So therefore, so again, go to components and select all. And when you select all, you can, and these are the components, right? These are the components, and you have a search bar here as well, right? So you can see there are lots of devices here under all components, right? So there are many components, ICs, Arduino, sensors as such, right? So these are the all components which are available. And just for knowledge, I will select basic, and you can see there are actually really less here, right? Only a small amount of devices are here when you select basic. So that's why I'm asking you to select all always. You can see there are plenty of devices now, right? So up to that part, are you all clear? Is it all clear for you?
Yes, sir. Clear.
Okay. All right. So let's make a small circuit using Arduino. Okay. All right. Okay. Shall we make a small code? Shall we make a small circuit?
Okay, sir.
Brilliant.
Yes, sir.
Okay. Nice. Okay. So first of all, now we are going to use Arduino, right? So we need an Arduino board. And I'm going to simply blink an LED today, right? So we'll start with the very most basic program, right? So you need to search. You can type Arduino, right? And you can see these are the controllers, right? So these are some example codes, right? So let's not go for that. Let's select this, and you can grab and drop it to your space, and you can zoom in and zoom out. And if you want, you can name it, right? So Arduino board, you don't necessarily have to name, right? Okay. Did you all grab and dropped the Arduino board to the desktop?
Yes, sir.
Brilliant, brilliant.
Yes, sir.
Okay. How about you, Dhahamsa? And
Yes, sir.
okay. Brilliant. Right. So then we are going to get an LED, right? So cancel this off, because we are going to connect an LED, and we're going to blink the LED, right? So for that, we need to find an LED. So I'm scrolling down. You also can scroll down and find an LED. So here you can see under outputs, there's an LED. So this is what we're going to use, right? And you only see the color red here. You drag and drop it here, right? But then when you select it, you will be getting this menu, right? So under its name, it's one. If you want, you can name it. But from here, you can change the color. So from red, blue, orange, yellow, green, and white. So I'm going to select color blue. So you can see my LED turned blue now, right? So likewise, you can change the color of the LED as well.
Okay, sir.
Okay, brilliant. Okay. All right. So let me zoom the LED, right? So you can clearly see this. In this LED is a diode, right? Diode is a device which only allows the current to flow in one direction, right? Again, we will learn a little bit of electronics in a different lecture session, right? So I'm like giving you a complete picture what you're going to learn, right? So you're going to learn separately about sensors, separately about actuators, and separately about electronics as well, right? But before that, I want you to know this, right? So in this LED, there are two types of pins. One is called anode and other one is called cathode, right? So how to identify this is from this shape in Tinkercad, right? But in real life, there will be two pins from the LED and one pin is longer than the other, right? So this longer pin, or else in this diagram, this angled pin is actually the positive pin, right? Positive voltage pin. And then the straight pin, or in real life, the shorter pin is actually the negative pin, right? So that you keep it in your mind. Okay. Right. And then what I'm trying to do is I'm going to connect this, right? So as you can see, I'm going to connect this negative pin to the ground, right? So on Arduino, we have ground. So negative is actually the ground here, right? So the shorter or the straight pin is the ground, and angled or the longer pin is the positive pin of the LED, right? So therefore, I'm going to select, you can work along with me, right? I'm going to select a wire, a normal wire, and I'm going to select the color, let's say brown, right? So I'm going to select brown and connect it to the ground. So when you can connect, or when it's successfully connected, you can see it is glowing, right? So it indicates the Arduino and the pin, right? So here you can see this red box, which means I have selected the pin, right? And when you select this also, you can see I have selected the pin. So make sure that you get this red color box, otherwise it won't successfully connect, right? So I have connected the ground pin, and then there's a small thing with the LED, with LEDs, okay? So what is that small thing, right? LEDs, right? They usually work in 3.3 volts, right? But the Arduino is actually supplying 5 volts, right? So when you give 5 volts to the LED, there will be lots of current going and it might burn the LED, right? So in order to prevent burning, we are connecting a resistor in between, right? So the resistor is a device which helps us to limit the current, right? So we are controlling the current. We have to limit the current, otherwise the LED will burn, right? So if you provide 3.3 volts, then no problem. But I'm gonna give power to this LED from this 13th pin, pin number 13th, right? So this pin number 13 give 5 volts, and the LED might burn if I provide 5 volt, right? Because there will be bigger current. So therefore, I'm using this resistor. I'm going to drag and drop the resistor here in order for me to control the current, right? So now I'm connecting this with a different color. I'm going to use red, right? So I'm going to connect this LED's angle pin and this one, and then from this to the 13th pin, right? And as you can see,
We can.
I tried it and the light blinked, but not go straight. Like it's blinking.
yeah, okay, okay. And we're gonna use that. How did you blink the light? Did you write any code?
No, sir.
We
Just I like start. I clicked on start simulation and it blinked.
All right, okay, okay, okay. Let's see, let's see.
can
Sorry?
the pin 13. We can use only the pin 13.
No. We can use 13, 12, 11, 10, 9, 8, 7, 6, 5 until this 2. We can use.
I
Yes.
didn't code, but I connect those small blocks from blocks.
All right, from blocks. You meant. Right, okay,
Yeah.
okay. Okay, so I'll explain how to do that using code, okay? Using coding.
Okay.
All right. Brilliant, right? So this is the idea, right? So when you drag, and again I will show you something. So when you drag and drop, and when you select it, and you can rotate this device like this, right? So you can see I'm rotating it, right? So you can rotate, right? But this I will delete it. Okay. So for this resistor, there is no correct side. You can connect it any side you want, right? But for this, you need to give a value, right? So I'm going to select this resistor. If I want, I can name it, but I don't want to name it now. I'm going to give, first of all, I'm going to change this from kilo ohms. So this is kilo ohms, right? Kilo ohms to ohms, just ohms, right? And then I'm going to type here 330. And we will learn why I use these numbers in the future, right? So that the value of the resistor is 330 ohms, right? And you can see when I type numbers, the colors of the LED, colors of the resistor, the ring color of the resistor is changing, right? Why is that? Because in real life, we identify this resistor. Okay, so this resistor is a 330 ohm resistor using these colored rings. Like I will explain you in the electronics lecture session how we select resistors from these colored bands, right? So for now, I want you to change it to 330 and just ohms. Okay, right. And now we're gonna code, right? So now all the connection is done. Have you all connected up to this point and changed the resistor value?
Yes, sir.
Okay. How about others?
Yes, sir.
Okay, brilliant. Now I want you to go to this code, right? And from this code, you can see it is already built. It has already built something, right? So this program is somewhat intelligent, right? And this is called blocks. So you can see these are blocks that you can move and drag and drop like such, right? So we are not going to, so you can delete the block if you want, but we are not going to use the blocks. We are going to go with text, with code, right? So it gives you the caution sign. Yes, it says the code, the blocks which are already there will be lost, but that is fine. We are going to select continue. And you can see here, there is this program, there's this code written here inbuilt. Why? Because this is smart, right? So when we connect this, it has actually written some code here, right?
Sir, also,
Yes.
also I changed the time duration that
Right, brilliant.
must take lights.
Yes, so we can,
Just 3 seconds.
okay, brilliant. So we can try that, right? So for others, now I think you also have this code written here automatically, right? Is that correct? Is that correct? How about others? Do you have this code here written automatically?
Yes, sir.
Okay. How about others?
Yes, sir.
Okay. Right. So without doing anything, shall we just select this button and see whether it is working? Start simulating. Shall we start that? So I'm going to select, I'm going to press it. So it is initializing, and you can see now the LED is blinking, right? So you can see my LED is blinking here, right? Okay. Right. So when it's simulating, there's nothing much that you can do, right? So you can't type anything because it's simulating, right? So therefore, we need to stop simulating in order for us to make a change. Yes? Is that a question? Sorry?
Stop blinking කියලා එහෙම දැම්මොත් එක හරියනවා.
නෑ stop blinking කියලා අපිට type කරලා හරියන්නේ නෑ. හරිද? ඒ code blocks වලනේ. දැන් අපි කරන්න යන්නේ coding, right? Simple coding. Okay. Right? So therefore, I'm going to now do a small change to this code, right? I'm a code එකට පොඩි වෙනසක් කරන්න යන්නේ. So first of all, I'm going to stop simulating, right? So you can see LED stopped blinking. And here, again, in the Arduino programming and all, we're going to learn thoroughly about this setup and loop, right? So just for an idea, keep it in your mind, this setup is more like the initial configuration. ඒ කියන්නේ මේ setup කියන්නේ අපි මුලින්ම මේ code එකේ ලියනවා මෙන්න මේ parts තියෙනවා මෙන්න මේ දේවල් තියෙනවා කියන එක. So that is the setup, right? So in this setup we introduce, okay, so there is an LED connected to the board, right? There's a motor connected to the board, or there's a sensor connected to the board. That is a setup. We are setting it up, right? And then there's another part which is called the loop. So the loop has its own meaning. It is looping itself, which means this piece of code is looping, right? So these are tasks, some task, and then repeat that again, and then repeat that again. So likewise, it is looping forever, right? So first of all, I'm going to do this change. So you can see in this first line, it says pin mode, LED built-in, and output. So let's see what is this, right? What does it mean? So the pin mode is the mode. Pin mode කියන්නේ අපි ඉන්න mode එක. ඒ කියන්නේ අපි පාවිච්චි කරන්නේ මේ එක pin එකක් power දෙන්න to give voltage. So we are using this pin. We are using these pins, or in this case, this 13th pin, to give power to the LED, right? So that is why it is in the pin mode, right? And then this LED built in, right? So this is a specialized code, right? So this 13, pin number 13 Especially they have labeled it as LED built-in, right? So there's another word for pin number 13 is LED built-in, right? And now what I'm going to do is I'm going to delete this LED built-in and I'm going to type just 13 here. So you can see it is typing with a different color, right? And then I have this output. Output means give power, output. So give an output. So generally the output voltage is 5 volts. Therefore, there will be 5 volts coming from this pin, right? So the only change that I did was I changed this LED built-in to 13, which means 13th pin that I'm representing, right? So here also I'm going to change it. LED built-in to 13, right? And here also LED built-in 13. And I will explain this loop part in a bit, right? So I want you all to change the LED built-in to 13, which represent the 13th pin. Have you all done it up to that part? You all clear?
Yes, sir.
Okay,
Sir.
brilliant. So shall we just start simulating and see whether it's working or not? So I'm going to select start simulating. It's going to initialize and you can see now this is blinking, right? Okay. So now I'm going to give you a small task. I want you to connect this LED to the pin number 10. Can you do that change and make it work? I will give you exactly 5 minutes, or like, let's say 5 is too long. I'll give you like 2 minutes. Now this LED is working from pin number 13, right? I want you to change the code so that I want you to connect this LED to the pin 12, sorry, pin 10, pin number 10 and make it work, right? So there is a small change that you need to do physically. You need to change the connection and you need to change the code as well, right? So I'll give you 2 minutes. So I want you all to connect the LED to pin number 10. And once you are done, please let me know.
Done, sir.
Is it working?
Yes, sir.
Okay. So let me do the changes as well. So first of all, I'm gonna select this wire and delete it. And then I'm gonna,
Change the seat or what?
sorry,
Not blink.
sorry.
Delay ka zero karama then blink na.
Delay ka zero karot, it depends. Mona delay ka the zero karanne කියලා. එක delay එකක් zero කරොත් blink වෙන්නේ නැහැ. එක delay එකක්
13.
zero කරොත් පත්තු වෙන්න තියෙනවා.
13 okay 13
නෑ. දැන් මම කරන්න දැන් අපි ඉස්සෙල්ලම කරන්නේ මොකද්ද? අපි ඉස්සෙල්ලම කරන්න යන්නේ මේ LED එක pin number 10 වලින් වැඩ කරනවා විදියට හදා ගන්නවා. Right? So ඒක කරාද?
yes sir.
Okay, brilliant. So how you do that is by changing this to pin number 10. I changed the physical connection to 10 and here also 10 and 10. Right? So it's very easy, right? So you can see the LED is blinking. All right. So let me explain this loop part, right? So in this loop, if I explain you line by line from this first line, or else the 10th line is actually, let's say the 10th line. 10th line says digital write. So digital write is a command. So when you type code, right? So when you do programming, we write commands. So there are a set of commands. So these commands are different to different languages, right? So in Sinhala, api Sinhalen kiyana yanna kiyala, right? And in English, we tell go, right? So likewise, in different languages, there are different set of commands. So here we are using Arduino OS C++ code, right? So in here, digital write means, can digital write කියලා කියන්නේ ඒ pin එකට අපි දෙන command එකක්, right? ඒ command එකකින් එයා ඒ pin එක write කරනවා, or else from that command it write to that pin, right? Just keep that in your mind, right? And then here within brackets, so this is entire thing is a command, right? So in brackets you need to tell what is the pin and whether it is high or low, right? So in digital write mode, right? So in digital write mode, first of all, you need to give what is the pin number, and then to set that pin high or low. High means give 5 volts, low means don't give 5 volts, right? So from the first line, or else from the 10th line, it says digital write, so that is a command, to the 10th pin. You write to the 10th pin high. When you write to the 10th pin high, what happens is this Arduino board will start providing 5 volts from this 10th pin, right? So that is what it does. And then delay 1000. 1000 means milliseconds, right? So 1 second is 1000 milliseconds. So that is why it is 1000 here. So here delay 1 second, or delay 1000 milliseconds. So first from the line 10, it says digital write. You write to the pin number 10 high. So which means, okay, give 5 volts from the pin number 10, and then delay. Wait for 1 second, right? So this loop is executing line by line. Sorry. Like I said, this code is executing line by line. First, it goes for this line. Second, it goes for this line, right? Third, it goes for this line. Fourth is goes for this line. And then after that, it's looping. It goes back to the 10th line, 11th line, 12th line, 13th line, again, 10th line. Likewise, it is looping, right? But it always goes according to the line. It always goes line by line, right? So first of all, digital write to pin number 10, you make it high, which means provide 5 volts. High means 5 volts, low means 0 volts, right? So you provide 5 volts here, right? So the LED start blinking, and then wait for 1 second, right? Wait for 1 second, and then digital write again, the same command, pin number 10, okay, the same pin, low. Now what is here? Now what's happening here? Low means provide 0 volts, or just do nothing, 0 volts, right? So 0 volt means LED stops lighting up, and then wait for another second, right? So, and then it goes back to the top, to the loop, and then again digital write pin number 10 high. Now again it lighting up, and again it waits for 1 second, and then again it lights off, and then again it waits for 1 second, lights off, and then it goes back high, which means lighting up. So that is how this code is blinking, right? Is that all clear for you? ඒ ටික පැහැදිලිද? Is that all clear? I want you to unmute your mics and speak up.
Yes, sir. Clear.
Everyone, is it clear for you? The Hamsa, Ayodhya?
Yes, sir.
Okay, right. So then, now one of you asked the question, right? How to stop this blinking? So first of all, let's try to change these values, right? So I want you to change this value to 100. 100 milliseconds, you keep the LED lighted up. And then 1000, 1 second, 1000 milliseconds, you keep the LED switched off, right? And then shall we simulate this and see? So you can see it is now blinking like a signal light, right? So it blinks fast, right? It blinks fast. And then I want you all to reduce this value, this second delay, which means the delay which keep the LED low, also 100. Now let's see, it will blink faster. See, it is blinking very rapidly, right? Right. So likewise, you can change. And as you asked, I think you asked how to stop this blinking. There are many ways. One way is actually reduce this delay to 1 millisecond, right? So 1 millisecond is a very small time. So your eyes won't see it is switching off, right? And then let's see. So you can see it is already. So this actually blinks, but it blinks in a much faster rate. So your eyes can't see that, right? So it lighting up for 100 milliseconds and it switch off for 1 millisecond. So 1 millisecond is a very tiny time interval, right? So therefore your eyes won't see. So that is one way of keep this lighted up, right? And then the other way is by commenting all these out, right? These two out. So I don't want this LED to switch off. So I don't need this line there. Is that clear? If I don't want this LED to blink, if I don't want this LED to switch off even for a second, even for a microsecond, I can simply take this line out, right? So there are two ways. One way is to delete this line and the other way is to type 2 forward slash. 2 forward slash means we are commenting it out. So you can see they have already written a comment. So whenever you want to write something which you don't want to execute or which is like a detail, like here they have written a detail here, right? What this delay means is to wait for 1000 milliseconds. So this wait for 1000 millisecond sentence is not a part of this code, right? So then they have set it as a comment. So how to set it, how to type a comment is by typing 2 forward slashes and then type what you want. Similarly, what I have done here is I have commented this code out. So this was initially a part of our code, but when I type this 2 forward slash, then it becomes a comment or a non-functioning line of the code. This line will not function now. So it has changed the color as well. And I'm gonna type this, I'm gonna comment out this delay line as well. And let's see what happens now. So you can see the LED digital write to pin number 10. So to pin number 10 high and then stay for 100 milliseconds. And then these two lines won't execute because it is already commented out, right? These two lines no longer function and then it loops back to right, to stay high. So it will keep on staying high forever. right? So are you all clear now?
Yes, sir.
Okay,
Yes, sir.
brilliant. So as we don't usually like give homework, right? Because this is a, because I don't think you, any of you like homework, right? You may have lots of other school homework to do, but if you get a time, right? If you get free time, right? So I'm not going to mark, but let's do this exercise in the next day as well. If you have time, just try to put another light here to a different pin, right? To a different pin, another light, and try to switch it back and forth as such, or like together, you know? So just try that and see. And next time when we meet, just let me know whether you did it or not, right? So I will give you a small tip. You can see this is a ground pin, right? And here also you have a ground, two ground pins. G and D means ground. There are two ground pins here, one ground pin here. So there are altogether three ground pins, right? So you can use any of these ground pins to connect your LED's ground pin, right? So when you are using two LEDs, you will use two different pins to power up the LED, right? But then you have to connect your LED to the ground. So you can use the same ground, or else you can use these two grounds in this side as well, right? Is that clear? So if you have free time, just try to add another LED and see. And if you want to add 3 or 4, just go ahead, right? If you really try, you may be able to like come up with a very nice patterns as well, right? Is that all clear for you?
Yes, sir. Clear.
Brilliant. And I have a small notice actually. Due to an unavoidable circumstances, like unavoidable reason, I won't be able to conduct the class next week, right? So keep it in your mind, 12th, which means the next Sunday, there will be no classes. Is that clear? I'm very sorry. I won't be able to conduct the class on the next week, right? On next Sunday, there's no class on 12th. Is that clear?
Yes, sir.
Okay, so from 18th, we'll start, right? Clear?
Yes, sir.
Yeah.
Yes, sir.
So the next class will be, sorry, not 18th, 19th. Okay. So the next class is 19th. All right. So I'll
Sir, please share the mic in WhatsApp group.
yes, I will share that in the WhatsApp group. Yes, I will add these parts as well. Okay, the Tinkercad slides as well, because like we did it, no, or else I think I be able to send a link for this recording as well, right?
Okay, sir.
All right.
Yes, sir.
So yeah, so let's stop the session for now, and thank you very much again. And I think you guys are really good, so we can do this course very quickly and very nicely. We can complete it. Okay, so let's keep the enthusiasm as the same, right? So be excited. And now Tinkercad is yours, so you can build different circuits, and you can ask me questions how to build it. If you came across with problems, you can just ask me. Okay, right? So
Okay, sir.
brilliant. So I'll
Sir.
see you. Yeah.
Sir, I want to ask you,
Yes, ask.
is there is a chance that you can do it next week?
There is no chance. That's the problem. Why did you ask that?
No, I was a little bit excited.
Right. Okay. Let's see. I'm not sure, but I might be able to put a small recording maybe. Right? Let's see something like
Okay.
that. Right. That is not sure, but yeah, because you are very excited, I don't want to discourage you as well. So therefore, I'll try to do some recording, and it'll be like a small example or exercise, right? How about that?
Okay, sir. That's
Okay,
great.
brilliant, brilliant, brilliant. All right, so then I will meet you on 19th. Okay, so until then, stay safe, be safe, and yes, I will see you guys on 19th. Okay.
Thank you, sir.
Okay, sir.
Okay,
Goodbye.
welcome. Thank you. Bye. Good night.